Okay, guys. So as we were saying, a geometric progression is a sequence where the pattern is that we are taking a sub 1, the initial value, and we are multiplying that value by a number all the time, over and over again, okay? Like in this situation. So this sequence, which is given by 1 times 2 raised to the power of n minus 1, because on each day we are multiplying by 2. So the first day we have 1 person infected, the second day we have 2 new people infected, third day 4 new people infected, 8, 16, and so on. Then this geometric sequence is showing us the new people infected, okay? Then the series, which is the addition of the terms in that sequence, is giving us the total amount of people infected. Not the new people infected, but the total. So this is the cumulative total, as we call. Es el total acumulado. Okay, we are adding the terms of the sequence. So on the first day, there is 1 person infected. Second day, we have a total of 3 people infected. Third day, we have a total of 7 people infected, 15, 31, and so on. So in a geometric series, same as we did with an arithmetic series, we have that if we have to find S sub n, okay, any term of the series, what we are going to do is we are going to add a sub 1 plus blah, 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 until a sub n, okay? Or if we write it with sigma notation, as I explained before, this is from n equals 1, well, up to n. Here, this is a bit confusing. Maybe let me do it with numbers. So if I find a sub 5, this is a sub 5 from 1 to 5 of the corresponding sequence. Okay? So the series is the addition of several terms. Sorry, this is not a plus, this is an equal sign. So the S sub 5 is the addition of the first 5 terms, which can also be written like this. Okay, good. This is what we call the finite series. Let me copy all of this here. Okay, so here, as we were explaining before, this pattern is described by this 1 times 2 raised to the power of n minus 1 new people infected. How many people are infected in total at the end of the 5th day? Okay, then I can compute S sub 5, which is the addition of the first 5 terms of the sequence which is this. So I just take the first 5 terms, 1 plus 2 plus 4 plus 8 plus 16, and it gives me 31. Okay, but the same as happened with uh, arithmetic series, there is a formula. Okay, because if I have to find S sub 100, I don't want to be adding 1 by 1. So there is a formula. And the formula is this one. It's not the same as with arithmetic series, but it's a bit similar, okay? It's a sub 1 times 1 minus the ratio raised to the power of n, okay? Divided by 1 minus the ratio. And this formula gives me any term of the series that I want. So let's compute this again, but using the formula. A sub 1, which was the original, I found this before. This was the sequence, okay? Okay, good. So here, I'm going to use the formula. So I'm going to take a sub 1, and a sub 1 was this number, 1. Okay, so this a sub 1 is 1. Then 1 minus r raised to the power of n. R is the ratio, so it's 2. Raised to the power of n, what is n? Okay, I'm finding s sub 5. So n equals 5. Easy. And down here, 1 minus the ratio, and the ratio is 2. Okay, very easy. Then this one is not doing anything, so we can just get rid of it. So this is 1 minus 2 raised to the power of 5 is 32. And down here we have minus 1. So this is 1 minus 32 is minus 31 divided by minus 1, positive 31. We get the same result. Okay. And why is this called finite series, serie finita? Because it has an end. Okay. We are adding from a specific value up to another specific value. From 1 to 5, the first 5 terms, it's finite, es finita. Okay. It does have an end. We are taking a specific number of values and we are adding them together. Okay, so this is a finite series which uses this formula. Okay, and we could do this to find any term of the series. I'm going to stop recording here for a minute.